Okay, so welcome back. Now that we've had some time going over an informal definition of a limit and also an intuitive idea of a limit, and we've done lots of examples, so by now you should have a very good intuitive understanding of what a limit is. And so now it's time to start getting into the formal definition of what a limit is. Okay, and so this is the precise mathematical definition of what we use when we talk about a limit. And so before we do that, we're going to have to introduce you to some concepts, some ideas that is going to be necessary when we get to the definition of a limit in the next video. Okay, so in this idea of going from the informal, intuitive understanding of a limit to the formal definition of a limit, we have to understand what it means by closeness, right? So far we've been dealing with vague ideas of what it means to be close. So now we're going to quantify what that means in mathematical terms. So remember that the absolute value between 2 points, the absolute value of the difference between 2 points is the distance between those 2 points. So the absolute value of a minus b is the distance between 2 points on the number line. Okay? Now, with that in mind, this here is we're taking the distance between the function, the value of the function at x, and the limit L. And so we're taking the absolute value of that, so we're saying the distance between the function and the limit is less than some real number epsilon. Okay. Now this is also equivalent, it's important to notice this is also equivalent to saying that the value of the function is going to be between these two values. The limit plus some real number epsilon and the limit minus some real number epsilon, where epsilon is some small number. Okay? And then also, we have this symbolism here, which is saying that, hey, 0 is less than this distance, so the distance between x and some real number a, is greater than 0, which means what we're saying is x is not equal to a, right? So this part here is telling us that x is not equal to a, but we're also saying that this distance is less than some real number, delta. Okay? Which again is equivalent to saying this, that x is going to be within this band of a plus some real number delta and some a minus some real number delta. So we have this interval, right? So this is interval notation that we're looking at. And of course, we're also saying that x is not equal to a in this case. Okay. So now, with this framework, now what we're going to do is we're going to introduce the precise definition, the formal definition of what a limit is in the next video. Okay? See you then.